Okay, let us consider an example for this bisection method. So, for this bisection method, we are having, let's consider equation like this: f of x equal to x to the power 5 minus 4x minus 9. Now, first step, what you had to do is that find out what is the value of f of 0, f of 1, f of 2, f of 3, etc. So that we will have a positive value for the f of the function, and we also need a negative value for the function. Okay. When you are having a positive value for the function and a negative value for the function, then you choose those x values where you will get these negative and positive values as your interval. So, we are having f of 2 is negative in here and f of 3 is positive, hence the roots of the equation lies between 2 and 3, these are the x values, which implies a equal to 2 and b equal to 3. That is your interval. So, that in between those interval your function f of x should have 0. Now, you calculate the midpoint. In this case, we are considering this as the first midpoint calculation. So, we take it as x1. So, x1 equal to a plus b by 2, which will give you 2.5, which is nothing but 5 by 2, and calculate what is the value of f of 2.5, and you can see this is negative. F of 2.5 is negative. Now, you are getting f of 2.5 is negative value, which means that f of 3, okay, here you are having f of 2.5 is negative and f of 3 is positive, hence the roots lies between 2.5 and 3, because initially we assumed the negative value at x equal to 2, and we took a equal to 2 as one of the boundary point or the interval. But in this case, we have found that f of 2.5 is also negative. So, when your f of 2.5 is negative and f of 3 is negative, f of x will be in between. When f of x equal to 0, that will be in between 2.5 and 3. Okay. Then we have to replace this a with 2.5 and b equal to 3. Again, you calculate what is the midpoint. So, x2 will be equal to a plus b by 2, which is equal to 2.5 plus 3 by 2, which will give you 2.75. Now, what is the f of 2.75 that you had to calculate? F of 2.75, and it will give you 0.797. So, this is a positive quantity. Okay. So, when it is positive, then you are having f of 2.5 as negative, right, and f of 2.75 as your positive value. So, the roots lies between 2.5 and 2.75. Initially, we were having the positive value of f of 3, but now you have reduced that to 2.75, because when you calculated this f of 2.75, that also give you a positive value. So, we reduced the interval to 2.75. Now, the roots lies between 2.5 and 2.75. So, initially we considered 2 and 3 as your interval. Okay. Then you reduced 2 into 2.5. Sorry, in this case you have increased 2 to 2.5, 3 you reduced to 2.75, and in between these two values, when you substitute some x, you will get f of x equal to 0. Okay. So, this value of x we had to find out, and we had to reduce this with different steps. We have to reduce again and again, and we will find out what is the value of x when the f of x become almost 0. Okay. So, if you calculate this in a repeated way, then you can see the x3 value is 2.625, x4 is 2.6875, etc. up to x7 I have calculated here, and you put the condition f of xm which is less than 0.0001. So, at any of these cases, if you are getting this condition f of xm is less than 0.00001, then you can have your solution, that is this xm will be your final solution, where you will be getting f of x almost equal to 0. Okay. So, that is the bisection method. So, I hope you understood this concept. Okay. So, in each cases you have to substitute the value of x of 3, x of x4, x5, x6, all those values substitute in your function f of x and calculate what is the value. And when you get that f of x value which is less than 0.00001, which means that it is almost equal to 0, that corresponding x value, that is x of 7 or x of 6, whatever it is, that will be your solution. Okay. So, this is how we calculate the solution by using bisection method, where you have to first you have to take the intervals, then you reduce that interval in such a way that you are approaching towards f of x equal to 0.